Hello students, in today's class we shall discuss the law of conservation of mass and its limitations and how to solve the questions based on the law of conservation of mass by taking some examples. Law of conservation of mass. So this law of conservation of mass was proposed by Lavoisier and it was verified later by Landolt. The definition of the law of conservation of mass is the matter can neither be created nor be destroyed. So, if we see, the name of the law is the law of conservation of mass and the definition is given as based on the matter. So, let us discuss about these 2 points along with the observations made by the Lavoisier. Actually, Lavoisier conducted many experiments based on the thermal decomposition of the matter. So, he basically conducted experiments, thermal decomposition. So, in this thermal decomposition, then he observed that during the process, it may be physical process or it may be chemical change, the mass of the system completely remains constant. So, based on that only he proposed this particular law as, this can also be written as the mass can neither be created nor be destroyed. Then the question arises whether these two are same or similar. Actually, these two are not 100% same. That we shall discuss by taking some examples in the coming discussions. So, let us discuss about how to justify the mass can neither be created nor be destroyed. And finally, we will come back to why the matter can neither be created nor be destroyed. So, first of all, based on this particular definition, so the mass can neither be created nor be destroyed, or this can also be written as for a chemical reaction. The total mass of the reactants is equals to the total mass of the products. So here mass remains constant. That is possible when the total mass of the reactants is equals total mass of the products. So this particular definition is applicable only when the reactants are completely converted into the products. Let us take an example here. Imagine there is a reaction between A and B and it is producing C and D. The mass of A is, let it be m grams, whereas B is n grams, C is x grams, whereas D is y grams. So now if you apply this particular definition, that is the total mass of the reactants is equals to the total mass of the products, then mass of the reactants m plus n is equals to the mass of the products x plus y. Let us take an example that is justifying this particular definition. That is example 1. Imagine there is a reaction in which silver nitrate reacts with potassium chloride and produces silver chloride and potassium nitrate. Silver chloride is a white precipitate. So in this reaction, let us imagine that 170 grams of silver nitrate has been taken, whereas 74.5 grams of potassium chloride was used, and finally imagine 143.5 grams of silver chloride has been produced, and we don't know what amount of mass of the potassium nitrate has been produced. That we can solve by using this particular formula. That is, according to this, mass of the silver nitrate plus mass of the potassium chloride, because both are reactants here. Mass of the total mass of the reactants is equals to total mass of the products, is equals to the mass of the silver chloride plus mass of the potassium nitrate. Then let us substitute these values here. This is 170 grams plus 74.5 grams. This is equals to 143.5 grams plus mass of the potassium nitrate that we would like to calculate. Then mass of the potassium nitrate is equals to 170 plus 74.5 grams minus 143.5 grams, that finally gives 101 grams. So by using this particular definition, we are able to calculate the mass of the either reactants or products if all others are given except one. Let us take another example also. That is, imagine calcium carbonate on decomposition produce calcium oxide plus carbon dioxide. So in this particular reaction, they have taken, imagine 10 grams of calcium carbonate has been taken and 10 grams completely decomposed and produces, imagine 5.6 grams of calcium oxide has been produced. Then what could be the mass of the carbon dioxide produced? Same like this. So here mass of the reactant, that is calcium carbonate, is equals to total mass of the products. What are the products here? Calcium oxide and carbon dioxide. So mass of the calcium oxide plus mass of the carbon dioxide, this is equals to 10 grams. Here this is equals to 5.6 grams plus mass of the carbon dioxide. Then mass of the carbon dioxide is equals to 10 minus 5.6 is equals to the 4.4 grams. So this formula we can apply only when the total reactants are converted into the completely products. Then what happens if the reactants are not completely converted into the products? Then means only partial amount of the reactants are converted into the products. Then the mass of the reactants reacted is equals to the mass of the products produced. So here means all the reactants are not converted. Whatever the amount of reactants converted, that much amount of the products only will be produced. So let us take the similar question. Example 3 now. Let us take calcium carbonate decomposes into the again calcium oxide plus carbon dioxide. But this time I have taken 100 grams of the calcium carbonate. But out of 100 grams, only 10 grams is participated in the process. Remaining 90 grams not participated. So the product's formation depends only on the amount of the substance that decomposed here. Whichever is not participating in the reaction, that cannot produce the products. That's why the mass of the reactants reacted. Only how much is reacted here? 10 grams of the calcium carbonate is reacted. Then remaining how much is produced? Imagine again 5.6 grams of the calcium oxide has been produced, and how much amount of the carbon dioxide has to be produced in this case? Similar. We can calculate that mass of the calcium carbonate is equals to the mass of the calcium oxide plus mass of the carbon dioxide. So finally mass of the carbon dioxide we get as a 4.4 grams. Then the question arises, can we apply the law of conservation of mass to all type of reactions? So whenever if you take this particular definition, the law of conservation of mass cannot be applied only to the nuclear reactions. So in case of nuclear reactions, usually mass, whatever the matter you have taken, that matter usually converted into the products plus some amount of energy. So let us see here, matter actually contains both mass and energy. And we know that mass and energy are interconvertible. Means mass can be converted into the energy. At the same time, energy also can be converted into the mass. Then if you consider only the mass of the substance, mass of the reaction remains constant, then when you take the nuclear reactions, in case of the nuclear reactions, some amount of the mass is converting into the energy. So there we can see the loss of amount of the mass. That is the reason why when you consider this particular definition, law of conservation of mass is not applicable to the nuclear reactions. But when you take this particular definition, the matter can neither be created nor be destroyed. It is applicable even to the nuclear reactions also. Why? Because according to this one, we know that matter contains which one? Both energy as well as mass. So whenever matter remains constant, automatically mass and energy of a particular system always remains constant as long as matter remains constant. If we consider only the mass, means then matter may or may not be constant. So that is the reason why law of conservation of mass is not applicable to the nuclear reactions. So let us try to solve one question. Here given question is 5 grams of potassium chlorate KClO3 yield 3.041 grams of the KCl and 1.36 liters of oxygen at STP. Show that these figures support the law of conservation of mass within limits of plus or minus 0.4% error. So let us try to solve this question. First of all, let us write down the data. So mass of KClO3 given as 5 grams and mass of potassium chloride given as 3.041 grams. So difference could be the mass of oxygen. This is what we are expecting. Why? Because they said some error is there in the reaction. So this is equals 1.959 grams. So let's calculate the mass of the oxygen using this particular given information. Volume is given. So mass of the oxygen is equals to given volume 1.36 liters divided by 22.4 liters into 32. 32 grams is the molecular mass. So this value is equals to, if we calculate this one, you will get the 1.943 grams. So difference of the mass. Difference of mass of oxygen. Starting mass how much? Here it is given 1.959 grams minus this is 1.943 grams. So this value equals 0.016 grams. So here it is, means this much error is there. Let us calculate the percentage of the error. So percentage of the error means difference of the mass 0.016 divided by total mass of the substance. Initially what we have taken 5 grams into 100, this is equals to 0.32 percentage. So 0.32 means it is a loss actually, because expected mass is 1.959 grams, but actually we obtained is 1.943 grams. So there is a loss. Loss means minus percentage. So they said either minus 0.42 plus 0.4. So it is actually within the limit of minus 0.4 percentage. So the law of conservation of mass is satisfied and supported. Let's try to solve another question. The given question is 0.22 grams of hydrocarbon. This hydrocarbon contains only carbon and hydrogen. On complete combustion with oxygen gave 0.9 grams of the water and 0.44 grams of the carbon dioxide. Show that these results are in accordance with the law of conservation of mass. So let's try to solve the question. So basically we have to keep one point in mind, that whenever hydrocarbon that contains only carbon and hydrogen undergoes decomposition process, complete decomposition process, carbon shall be converted into the carbon dioxide and hydrogen shall be converted into the water. Complete. So here hydrocarbon mass is given as 0.22 grams. 0.22 grams of hydrocarbon is present. Carbon dioxide produced is 0.44 grams. And oxygen produced is, means water produced here is 0.9 grams. Then if you apply that means total mass of the reactants is equals to total mass of the products directly, here we will get the wrong value. The reason here is this oxygen mass was not included here. So oxygen is added to the reactant molecule. So this is another reactant molecule involved whose information is not given. So but we have to show this particular process is obeying the law of conservation of mass. So let us try to calculate the carbon mass and hydrogen mass. The purpose of calculating the carbon and hydrogen mass is actual reactant molecule contains only carbon and hydrogen. And here also if carbon and hydrogen values is equal to this total value 0.22 grams, then this is obeying the law of conservation of mass. So let us try to calculate the first one. So the first one is carbon dioxide. Carbon dioxide molecular mass is 44 grams. So 44 grams of CO2 contains 12 grams of carbon. Then 0.44 grams of carbon dioxide contains how much mass of the carbon? So just do the cross multiplication. So mass of the carbon is equals to 0.44 into 12 divided by 44 grams. So you'll get the 0.12 grams of the carbon is present. Similarly, let us calculate the mass of the hydrogen. So actually hydrogen is the part of the water now. Oxygen and water together they are present. So we have to take the total molecular mass. Molecular mass of the water is 18 grams. 18 grams of H2O contains 2 grams of hydrogen. Then 0.9 grams of H2O contains how much mass of the hydrogen? So let us calculate the mass of the hydrogen is equal to second cross multiplication 0.9 into 2 divided by 18, it goes 9 times, so that it gives the 0.1 gram. Now we got the mass of the carbon, that is 0.12 grams, and mass of the hydrogen 0.1 gram. Let us add both of these. So total mass of carbon and hydrogen is equals to, that is 0.12 plus 0.1, this value equals to 0.22 grams. So 0.22 grams is the mass of the reactant molecule. That means now mass of the reactant molecule is equals to the mass of the product. That means the particular problem, this process obeys the law of conservation of mass. So I hope you understand this lecture. If you have any doubts regarding any concept, please do not forget to send your questions to the classroompoint@gmail.com. Thank you.